In this example, we're asked to find all the terms of a finite sequence. Remember, a sequence is a list of terms. So we're going to find a finite list of terms, and the nth term is defined by a sub n equals parenthesis -3 raised to the exponent n minus 2. And the reason this is finite is because of the next comment. 1 is less than or equal to n is less than or equal to 6. So the index runs from 1 all the way through and including 6. So we're going to find a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. Okay, that's why it's finite. Let's go ahead and find those values using this formula for the nth term. I want you to notice something about this formula. A sub n only depends on one variable, and that variable is the index n. That represents the position of the term in the list. So a sub 1 will be index 1, and it's the first position in the list, and the value of that first position is, now remember, n is the index, in this case is 1. We're using a sub n equals -3 to the n minus 2. So a sub 1 has to be equal to -3, in parentheses, raised to the 1 minus 2. In other words, that's base -3 raised to the -1. Well, you know what it means to have a negative exponent. You can flip it upside down, and the exponent changes sign. So it's 1 over base -3 raised to the positive 1. So that's just 1 over -3. So our answer for the first term is -1/3. Let's find the second term, a sub 2. In a sub 2, the index is n equals 2. So this second term is, using the formula, -3 raised to the 2 minus 2. So that's -3 to the 0. Any base raised to the 0 power is equal to 1. Let's find the third term, a sub 3. That's -3 raised to the 3 minus 2. So that's base -3 raised to the first power. That's equal to -3. The fourth term, a sub n, -3 to the n 4 minus 2. -3 to the second is positive 9, because -3 times -3 is positive 9. Now the fifth term, 5 minus 2 is 3, so it's -3 times -3 times -3. That turns out to be a -27. And the last term, now the reason I know this is the last term, because the indices only run from 1 to 6 in the given information. N is the index, and it only runs from 1 to 6. So this is the last one. A sub 6 equals -3 to the 6 minus 2, so that's to the 4th power. That's an even index of a negative base. The answer is going to be positive 81. And that's where we stop, because the given information was 1 less than or equal to the index n less than or equal to 6. So let's summarize our answer. All terms are, and I'm going to put it in set notation. I'm going to put this list. Now, you don't need to use any kind of set notation or parentheses. You can just list the values. That's what the text does. First term, a sub 1 is -1/3. Now put a comma, then list the second term. 1, that's a sub 2. A sub 3 is -3, then there's 9, -27, and 81. That's our list of the first 6 terms of this. Well, it's actually all the terms for this finite sequence that's limited by the index 1 to 6. Okay, now we don't have to always call the term a sub n. We can call it c sub n, b sub n, whatever. So here you go. Given c sub n equals parenthesis n minus 1 raised to the second power, and let's limit the index. Let's limit the index. 1 less than or equal to n, less than or equal to 5. Find all the terms. So we're going to find c sub 1, c sub 2, all the way through c sub 5. Okay, so you go ahead and stop the video, see if you can work it out, and come back to see the answer. There it is. The 5 terms are 0, that's c sub 1, then c sub 2 is 1, c sub 3 is 4, 1, 2, 3, c sub 4 is 9, and c sub 5 is 16.